hello. Thank you, Pi Gotham. Thanks for having me. And thanks for choosing to be here in this room to listen to my talk. For those of you that don't know me, my name's Owein Reese. I work at a company called Arena. That's arena.io if you want to go look for it on Google. Normally I give talks in strongly functional programming. This is going to be actually my first conference presentation on Python. But little dirty secret is that when I'm hacking at home or doing anything like setting up a website or web page or stuff, it's always in Python. Actually, I love this language. This talk is going to be broken up into 3 main sections. The first section is going to be sort of a review of anything that you might find from Google. If you go to Google Descriptors and you're like, what are these things? I kind of want to learn about them. But the next 2 sections are going to be taking that and going further with it. And they're designed to talk primarily to those people that may be writing libraries or frameworks. But if you're new to programming or new to Python in general, I hope that I've set up the slides such a way that even those parts will be digestible to you. And if you do have questions and we don't have time at the end, I will make myself available at the after hours show. Descriptors. So what are these things? Well, they're magic. They pretty much do everything in the world that you can imagine. Like if you have distributed programming problems, these things solve it. Concurrency, solve it. World hunger, solve it. All that stuff and more, right? Because as engineers, we haven't been oversold on overhyped technology ever, right? All right, so more seriously, descriptors. Now, there's going to be a lot of code here. So if you guys in the back, can you all see this? That's good. No? No, that was my fear. All right, I'm going to see if I can zoom this up a little bit more. Can you see it now? It's better? Rock on. All right, that's what I like to hear. And this makes it easier for me to do this. So descriptors are any class which implements one of these 3 dunder methods. That's the double underscore method. Dunder is actually something to do with like making rum. I don't even know how we got that, but dunder. So you get one of dunder get or set or delete. Just one of these and becomes a descriptor. But if you want it to be useful, you kind of want to implement the get. And if you're in 3.6 or later, you get this other method set name, which I'm not going to talk about really, and it doesn't make it a descriptor. So why would you care? Well, again, if you want to end world hunger, you should care, because descriptors, right? But no, actually, so these things properties, they're probably my second most favorite feature out of the language besides descriptors. If I look at what I've written up here, what are these doing? They're taking a function, they're hiding it, and making it look like an attribute, right? And each one of these, in this example, they're reaching out to your environment variable, and they're passing it into a single argument function. If you squint to the decrypt, it's sort of single argument. And if there was some extra like logic that needed to happen, that needed to be repeated here, or if I wanted to add like 3 or 4 more to this class, I might think about pulling this stuff out into a helper function and then delegating each of these calls. But I'd still have to write at property def, the name of my function, self, return self, dot, whatever. What you don't know, if you don't know about descriptors, is that under the hood, at property, or I should say at property, they're actually making a descriptor. So these sort of things, this is doing exactly what you would do at property, but if that logic that you have that you want to pair with state and you want to get it plugged into some reusable framework, well, Python's sort of object-oriented, and you can get that thing, pairing state with function, all together by using these descriptors. And now I've got essentially my attributes on a class that's reusable. I can push it around. I can go everywhere. So let's do an example. Let's go through and do a simple example of something that you might want to set up yourself. I like functional programming, so of course I like pretty much immutability as much as I can. So here's a nice naive example. I have some sort of value. I set it to none. If it's not set, I allow it to be set. If it is set, I throw an attribute error. And if I want to return it, I ignore all the arguments in this thunder get, and I just return that value. Awesome, right? Everything's good here. Except it's not. So when we assign a descriptor to something, we assign it to a class. And there's only one class in your program, right? That class is a singleton, and it's global. And so even though I had the dot value in the init method of that descriptor, I just made global mutable state, which is awesome, because we all love that. So if I assign that a.x, and I look at the value of the b.x, I've actually assigned that too. So that's not what we want. So it's this weird thing when you're working with descriptors and handling state, is that you actually want to do some sort of abstraction away, that you might be looking at your class, which has a descriptor, but the value stored for that class or what you want to do is actually housed in some other object. So I make a dictionary, and then the argument, this obj here, is actually the instantiation of the class. That is, when I knew the class, that's what gets passed in here. And this value is the thing that I want to assign. And so I reference this. I just say, OK, great. As long as this object is hashable, assign the value, and away I go. And you can get similar. And then you sort of avoid all these issues. So then I can go through and I can implement 30% of named tuple with 50 times the number of lines. That's awesome. Cool. So it works like this in init. I assign my values, they're right once. So I sort of have something that appears immutable. Now, that's cool, and that's good, and that's fun. And like I said, if you were to Google that for descriptors, and you want to reach for these things, 90% of the time, that's all you need to know. If that's it, if that's all you take away from this, great. That's wonderful. But let's try looking at, here we go, the right slide. Let's try looking at something else. Let's look at, hey, maybe I've got some value, and I want to attribute some axis parameters to it or something like that. I've got just some sort of metric I want to get, and I put it into this property field and push it out to production. It's great, and my startup booms, and now I have to hire people, and someone comes in and they look at this class and they go, hey man, what's this read counts thing doing? And my answer to that is, well, yeah, don't touch that. That's not important. But it's there. So my class is growing these weird appendages that really have nothing to do with the class in and of itself. And I don't want to come with some global metric or something like that, because those are a pain in the ass to mock for unit tests. So I might actually move this counter over to the descriptor. I can actually move that stuff over, and then I get the same thing as my attribute, and everything's good. And if you're wondering what's going up in the first two lines of this get, as I said, the object is the class when you knew it. But you can actually get the descriptors from the class object itself, in which case there's no object, it's none. And so this is often a pattern that you see is, OK, cool, if I want to get to the descriptor, I just return self in the get when I'm looking at the class. And that works, and that's pretty cool. But and there's a problem. Again, global mutable state. So even if you put it in the class, how many of you guys have ever worked with someone where you've had to sit down and be like, yeah, I know you can, but that doesn't mean you should. So they could still get in at the class level. They can still do some increment. They can still look at you and be like, yeah, I incremented it, but like, it was really hard to get to. I don't understand why you did that. And you're looking at them going like, yeah, I did that so you wouldn't do that. That doesn't exactly work. So what we have here in descriptors is one of the really cool and interesting features. And I don't know if there's any other way in Python really to do or get what you've got here. Look, this dunder get controls the access to the presentation of the data of the class. And what I mean by that is that I can choose how to display that information or the objects and the values, how they're returned. So I actually don't need to return the descriptor. And therefore, anything in the init or any of these publicly accessible methods that I might put into there, you can't get to. So that actually means that I have true encapsulation. You know, like other languages have these things called like private methods and stuff like that, and we have name mangling. Here I actually have a way to like hide all this stuff away, and they can't see it. What I can do is I can return some other object that may encapsulate that data and control how they look at it. So at the class level, they can only read the metrics. They can't actually modify anything going on. And at the actual object level, I can return like just a read-only version or some other thing that controls the encapsulated values that the descriptor represents. Because that's powerful, because now I don't have to have that conversation of, hey, why are you doing this? Stop touching that. And the next sort of thing that I want to go back on. And by the way, anyone have any questions on this before I move on? Cool. You may have actually seen, this is like a pattern that you often see in like ORMs and libraries like schematics, Marshmallow, or like SQL Alchemy, I think uses this as well. But we're going to have this interaction. And we're going to have this interaction where we have like some sort of like model class, and we're going to have some fields that are descriptors. And the model can't really exist without the fields, and the fields can't really exist without the model. In and of themselves, they just don't function. And I kind of want to take an aside here. So there's something else that I want to talk about, some concept. And again, I've only got 25 minutes, so I'm not really going to go too far into this, but it is a concept that I want to present, and then I'll use this concept to show you something that I'm going to do with descriptors. It's this idea of persistent data structures. How many of you actually know what a persistent data structure is? Can I see hands? Okay. Few of you, that way if I make a mistake, there's not a lot of you going, yeah, you're wrong. So immutable. Everybody knows what immutable is. That value, you can't change it. That means if I want to modify one of the fields, I actually have to make a whole copy of the object and change that field. Now I have two objects. And the concept here of persistent data structures is that sort of copying that I made, that persists the old state, and now I've got a new state. For truly mutable objects, if I want to do some sort of rollback, I have to know what the value was before. I have to make the modifications, see whatever side effects happened, undo the side effects, then reset the old value. I don't have to do that with immutable. Fully persistent is this weird sort of data structure where theoretically, to beginning of time, I've got a copy of every single version of that object that ever existed. This data structure can tell you about itself to the beginning of time. And more than that, I can go back to the beginning of time and I can modify and sort of branch off there. And if you don't get what I'm talking about, you will if I say git branches, and git essentially works like this. I can go back to any commit at any point in time, and then I can branch off and go that way. I've actually never seen a fully persistent data structure implemented. But what I have seen is this really cool thing called a partially persistent data structure. And that's what I'm going to do and set up and show you what we could work with and a problem that it could solve. So partially persistent data structure is something where, again, I can show you my past all the way theoretically to the beginning of time, but pragmatically we will probably limit it to some size. But I can only modify the very latest version or copy. Get back here. There we go. All right. So why is this useful? Why is this handy? Well, let's talk about async IO, because now we have asynchrony in Python, right? 3.x introduced this brand new world. So I have a request come in, and I have something that references a descriptor. So I had a polling descriptor before, hitting some URI, and every once in a while it may go and it may loop. So I'll go in and I'll process the request, and I'll hit this URI value, right? And I'll send it to some asynchronous loop, maybe another synchronous loop, and then away we go. But every time I do one of these, I actually give up control of the order of the operations. So what might happen is the web request will come in, reference this value, it'll do something asynchronous, the value will change. I'll do another thing that references this value, and then within my same web request, I now have an inconsistent state. And this kind of bug is going to hit you right about 4:30 Friday afternoon on your biggest, most important client, and now you have to stay, right? So you don't want to do that. What you want to do is you want to associate perhaps some sort of, shall we say, timestamp with your web request or something like that, where you can always go and you can always see what the value was when that request came in. And yeah, it may be stale, but if we were doing things in a synchronous manner, we'd do the full web request and then we go check that sucker. So it would be stale anyways. We haven't changed anything. We've just actually added a little more safety. So something that's partially persistent, if I tried to change it, I'm just going to make this like read-only copy, cache it away, and then update it. I mean, that's really essentially what I'm getting at here. So let's assume I have a model class, and it's got this sort of interface here where I've got something to persist a copy of it. I've got a method that says, OK, this is how you're going to go update it. And I'm going to have something that says, OK, begin polling, and a method that says, OK, give me the view at this particular time, or at least the view that was closest to that time. And this update may actually just look, again, same thing. I might actually look at the class level and loop through the fields that I have. And I may, in this case, have the field be able to reach out to a resource attached to the model, interrogate that resource, and return back the key value of that field. And the thing that we're trying to do here, the wonderful thing that we get is that the fields themselves, if I show you this, fields themselves, they're only responsible for two things. One is being able to serialize that value out of the resource, and the second is return the latest version. And the model itself is actually the thing that represents the structure in its entirety. So we do have this nice separation of concerns that happens here. So what might it look like when I get in a request? Well, let's say I got some resource or something out on S3. I hit it, and I look at this context, and it's version 3. But my web request, if I were to actually put in, say, give me the view of this thing at that timestamp, it's a different version. So, coming in and looking at this and setting these things up such that we can have the model class be concerned with representation and the field classes in terms of serialization, and then implementing in a persistent data structure, we avoid some of the issues of asynchrony. We get some nice, clean, safe code where at 4:30 you can actually go over to the fridge and say, OK, I'm having a soda and I'm going to watch YouTube for the rest of the day because that's how productive I am. So that's it. That's sort of like two two larger or more powerful sort of patterns or things to think about when you're working with descriptors, and an overview of essentially what descriptors are and how they work. So that's me on Twitter. If you want to, come out, reach out, talk to me, ask questions about anything. And if you have any questions about any of the code that I just showed or the things that I talk about, let's hear them. Anyone? Cool. Was my presentation that good, or you're just like, no, I don't want to ask anything? All right.
You talk about protecting the data from other developers or consumers of these APIs?
Yeah.
What are the use cases you think of?
So talking about protecting the data, are you looking back at like, let's see, this sort of thing? Is that what you're asking about?
Yeah. And like, what other use cases you think of?
Other than protecting and representation? Well, I mean, I'm sure there's lots of others if you want to use proxy classes. For me, this is pretty much saying that I want to make a division between how you look at the class itself and how you look at each individual object or instantation of that class, and such that the ergonomics of whatever library or framework I'm building, I control those ergonomics. I don't have to document certain things like, oh, this method is actually supposed to be private, or like do some sort of name mangling, because people can go into the dict anyways and try and look at it. So this sort of allows me to force a structured use of whatever code I write to whoever wants to consume it. And so perhaps, yeah, to answer your question, is that is actually what I'm doing, is I'm structuring my code like in a way that makes you use it the way I want you to use it if you want to incorporate it.
I didn't get your point of mutating the global state, because over here as well, the descriptor is mutating the global state as well, right? Starting by
This one?
yeah.
Yeah. But this is like a URI resource, so I mean, there's only one, right? So I don't care if it gets mutated, and this is presentation code. Please don't take this exact example and go out and put it in your code, because that's almost worse than, yeah, I Googled it. But yeah, I mean, like, look, if there's one thing, then there's one thing.
Other than the encapsulation and being able to hide stuff inside the descriptor, is there anything that you can do with a descriptor that you can't achieve with properties?
Is there anything you can do with a descriptor that you can't achieve with properties? So, yes, that's fine. I only have to write it once. That's what I can achieve with descriptors that I can't achieve with properties. You'll often see like the canonical example is non-negative numbers. So I do if this is less than 0, raise value error, else, assign. But I have to do that for every single time I want to define a new property. Or with a descriptor, I write a class that says if that's less than 0 in the setter, throw exception, otherwise, and there you go. Now I have 5 of them in my class.
Okay, yeah, that makes sense. I think I was more wondering from like a functionality standpoint.
Oh, from a functionality? No, I mean like properties they make a descriptor, so you could in a sense do that. Yeah, 1 minute. Anybody else? Sorry, is that a no? So I should also tell you all my code is like one class with like 40 descriptors, and nobody knows how it works but me. That's a great language feature. I call that job security, right? Yeah. Cool. All right. Well, thank you very much.